Hello and welcome in. My name is Mark, aka the Markster, and this is video number 49 in the FreeCAD series. So today we're going to make a gib for this dovetail. We go ahead and save this file under a different name. We'll call it dovetails with gib. Alright. Let me show which version I'm using before I forget. 0.19 revision 20036 on Windows 10. This is a development version. Alright, I turned that AC off. I'm not sure how much that noise is coming in. So we made this one with that taper, compound angle. We're not going to need that. So I'm going to delete these draft objects. And now you can see we've got just a straight straight dovetail. Let's look at this from this axonometric view. Alright, so what is a dovetail? I mean, what is a gib? You might be wondering. A gib is a little piece that fits in right about here between this part and this part, and you'll have some screws from the side here, and those screws, when you tighten them up, it pushes that gib up against this part and it adds a little more friction. Why would you want more friction? What you're doing really is taking out the slop, and by slop, let's see if we can get this to just kind of wiggle like that. If it's too loose, if the parts do not fit exactly well, you have a little wear maybe, you can adjust that out by tightening that gib up. So it lets you manufacture these not to the same exact tolerances and still be able to use them, and let you keep using them after you get some wear in there. So a lot of these old lathes, milling machines and what have you, they've been in service for near about a century, 70 or 80 years. You're going to have a lot of wear, especially if they were used in a production environment. So having that gib is a real benefit for that. So I did not add one in the last video, so I'm going to add one to it this time. Now we have a choice to make. Do we reduce the size of this one to make room? Do we reduce the size of this one to make room? Do we split the difference? I'm just going to create some room right here. We double click this body to make that active, and this sketch here. So I want to move this edge this direction some. How far depends on how thick we want to make this gib. So let's add a variable to our DD object. If you don't have this toolbar, you need to go to dynamic data, just visit it and come back. And when you do, that toolbar will follow you back. If you don't have dynamic data installed, obviously you need to install it. You can do that from Tools, Add-on Manager, Workbenches, look for dynamic data. Or you can use a spreadsheet to do something similar. So we want to add a new property, and that'll be this a length type, and that'll be this give depth, which let's try 5 millimeters. We'll see what that looks like. Now let's open the sketch back. Okay, so I have these symmetry constraints here. I don't want to interfere with those. So what I'm going to do is select, see, this edge, and this edge, turn them into construction mode, and then create a new set of edges here. To redefine this, these two are going to be parallel. We got 1 degree of freedom, and that's this depth. So let's set the distance between these 2 points, and that would be that the give depth parameter we just added. Okay, that looks a little thick for this model, but we're going to be making holes in it from this side, so I want to have enough meat there. We're going to need some holes, so this will let us take a look at this hole tool we haven't looked at yet. So let's make a sketch on the YZ plane, which is the side, and we need to move this sketch so that it's on this side here. Let's switch to the model tab, open the attachment offset, and you move in the Z direction. Even though in the global coordinate system this would actually be the X direction, when you're changing the attachment offset of an object, particular sketch, the Z is that direction normal to the plane of that object, and that's minus 30. But I don't want to just say minus 30. I would like to make this a little more parametric. So that'll be that width property divided by 2. And that's a minus we need here. So now if we change that width property, our sketch will align itself like we need it to. We could have attached to this face instead, but that would not be as robust against some bugs that we have in FreeCAD. Go back and watch the video if you haven't that I made on the topological naming issue if you would like more information about that. So we're going to put a few circles here. We need circles. I'm just going to put 2. We need circles to define where to put the hole. The diameter of a circle is irrelevant, but we need to set it regardless, just to get the thing fully constrained. So I'm applying horizontal constraining here, and the effect of that is both of these holes line up together. And I'm going to set the height property of just one of them now, and that'll be that H property divided by 2. That'll put it right in the middle, and next step is the diameter of these holes. So I'm going to create, let me close this and create a new DD property, and that will be screw, let's call it set screw diameter, and we'll put this at 5. So now back to the sketch. From the left side here. Let's set that diameter now. And that was set screw diameter. Again, this doesn't really matter what that radius or diameter is, because the hole tool will allow you to change whatever you want for your hole. Alright, now we need to lay these out horizontally. So what I'm going to use for this is I'm going to say 1/4 of that pad length and 3/4 of it. We need to make these both equals. Alright, so for the first one, it's 1/4 of the way there. So that's a minus property. And it's pad length divided by 4. Alright, and this one will be 3/4. So that's minus that pad length times 3/4. And now we'll use that hole tool. Select the sketch, create the hole. We need to go in the reverse direction, but there is no option in this task dialog for that, so we'll set it later. We'll choose isometric course. M5 size. I'm going to select threaded. Notice I got smaller. So what this does is when you select threaded, now it's not going to thread that hole, but it's going to set the size of the hole to the drill hole size that you need for this particular size thread for that tap. So it's the drill tap size for an M5 thread is 4.2 millimeters. Now that can vary depending on the type of material that you have. So if we were making this out of steel, we would use that 4.2. If we were making this out of plastic, we could go a little bit smaller, and that tap will still cut through that plastic. But anyway, now we come down here and we'll look for this reversed property and set that to true. So we've cut, the default length was 25 millimeters, but for a different set of dimensions, that might not be enough to go all the way through. And we don't want to use through all because we don't want holes on this side. So what I'm going to do is I'm just going to set this depth here to that width property divided by 2. So it drills all the way to the middle, but it's not going to affect this object because that's a different body. It's in a different body. So this hole is in this body. It's not going to affect this one. Now we're ready to start making that gib. So let's create a new body. Can't be based on that feature. So I had this selected, and when you create a new body, let me delete it just to show you. When you create a new body and you have an object selected, it will make that, let's go to party, it'll make that a base feature. And I'm just going to add a cube in here. I'm going to delete it in a moment. I just want to show you this. So if we select that cube and create the body, it makes a base feature. Now the cube is hidden, and let's hide these other two temporarily. So we see we have this cube integrated into the body as a base feature object. So that's what you can do. I'm just deleting these. When you have something selected, when you create that body, that's what happens. So the error was you can't create it from a feature of another body. You can't create a base feature. Alright, a little side trip there. So now we need a new sketch on the XZ plane to create this gib. We'll create a sketch here and pad that. So we create a sketch on the XZ plane, which is our front view. And what I would like to do is get some references to this other sketch. Let me just draw this out first, roughly. Alright, now in order to get references to the other sketch, that was this one here. I cannot create external links to external geometry to that sketch directly because it's in a different body. So what I have to do is create a go-between object, which is a shapebinder. So I select the sketch, and when I create the shapebinder, it goes into the currently active body, which is this one, the one we just made. It's not going into this body. That's not the active body. So select the create a new shapebinder and OK. Now let's hide that sketch, hide that body, hide this body, reopen the sketch, and you see that we have things that we can create references for. Let me delete these two constraints just to show you what we're doing here. We'll create a couple links to those 2 points, and I'll set this point coincidental to that one, this point coincidental to that one. This will be a horizontal edge. These two will be parallel. And this distance here is that gib depth parameter. Alright, and hide that, and we'll pad this out to pad length. And let's see how it looks now in relationship to the other objects. So that's what gib looks like. We did not have to allow for any clearance because that was already allowed for with these other sketches. So we already have a little bit of clearance. Alright, now we need to cut holes in this thing, but we don't cut all the way through. So the idea here is to have some screws going into here. This will be threaded. We're going to thread that after we make it with some taps. I'm not actually going to make this. Just pretend. And so it'll screw into here and go up against this gib and push it against there. But we need some little dimples, I guess you could call it, into here. Go in just a little ways, and that's going to let the set screw hold this in place, so that as this bottom piece moves in relation to the top piece, it's not knocking this thing out. But we don't want to go all the way through, because if we make the hole all the way through, then we're kind of defeating the purpose of having this. Alright, so we'll make a reference to this sketch like we did before. It's this one. Select it, create a new shape binder, and we can hide that one. And let's create a new sketch, this time on the YZ plane over to the side. We need to move it again like we did before. Detachment offset, the Z coordinate, and that was minus width divided by 2. Now we can use these references to create some circles in this sketch. Let's put one here and one here. Let's create the references. I want to hide these bodies because I don't want to. It's not letting me do it while that's open. I don't think let's close this. Close it and hide them first. Alright. Now. Okay, now we've got those two references made. Inside the shape binder. Switch to the left side to see this a little better. Alright, these will be coincidentally constrained, these two coincidentally constrained, and let's make all three of these the same size. So now we're fully constrained. And we can pocket this into there. But how far should the pocket go? We don't want to use through all, because we don't want the hole all the way through. Now I'm not sure what this dimension is. So what I'm going to do, let's go open the sketch again. So where would I like the hole to go? We could go to this point and it's going to be right here in the middle. That's going to put it pretty close to this back edge though. So these two are in alignment. How about to the middle of here? Let's add a point on this edge and set it symmetric, and then let's create a reference dimension between this point and this edge where the sketch is at. So this turns out to be 7.625. Is that going to be deep enough? Let's try it and see. If it's not, we'll adjust that a little more. So we come down here and give this a name. If we don't give it a name, we can't reference it. And we can't double click here to give it a name, because when you double click a reference mode constraint, it turns it into regular mode, and that would leave our sketch overly constrained. So this has to stay reference mode. Now you might ask, why this behavior? And it's not a bug, it's by design. This way, if your workflow habit is to create these reference mode constraints first, then you can go back and double click them to turn them into normal mode. That's not how I do it, but it's how the guy who wrote this code does it. So he kind of gets his way. His name is Abdullah. His username is Abdullah. He does just a fantastic job with the sketcher. So anyway, that's the reason for that. So we have to come over here, right click it, choose rename to give it a name. Let me try that again. And I'm going to call this set screw depth. So that'll be the depth of that cut from here. All right, everybody got that? So now let's select the sketch, and we'll do a pocket this time. And let's set it to that. That was in the sketch named female dot constraints dot set screw depth. Okay, so that's how deep our little holes went at that position. Is that enough? Is that far enough in? We would like to go a little further. Let's look at it in wireframe mode. So we still have quite a lot of meat left in here. So I think we can go in a little bit deeper without a problem. Let's go back to this sketch. So how can we go halfway here? We can add another point. And constrain that point symmetrically to these two. I guess we'll have to delete this one and redo it to that point. This time it's 8.875. I could just hand coded that in. Press an F2 here. It's a set screw depth. Has to be the same name or it's not going to work. Alright, now let's close the sketch and see how much deeper that hole went. Let's go to normal mode, as is mode. Yeah, so it's deeper than it was. Because we were like halfway up here before. So I like the looks of that. That's the depth I'm looking for. I don't want to go in too far to thin this out too much. Go back to normal mode. And now let's look at all of our parts. It's looking really good. Now, we have a workbench called fasteners in FreeCAD. If you don't have it installed already, you can get to it like we did before through the add-on manager. And that's the fasteners. You should install that. It's a really nice, useful workbench. Let's go into fasteners. Let's see, where are you? Here you are. And I'm going to select this edge. And I'm going to select this, what I call it, a cap head screw. That would be another option. I'll choose this one. Notice it put it in right where that circle was that I selected. And if we go to our dependency graph, we see that it's linked to the body, not to the internal pads or holes. That's what we want. We don't want any red arrows. Right, close that dependency graph. So now let's look at this screw. This is an M5, which is what we want, but it's not quite long enough, is it? I think we want a little bit longer screw. Again, it's okay if it's a little bit too long. And I'm going to set the thread to true. And what I'm curious about is, will these screws fit into that hole, or will it be too tight? So a way we can check this is to select our gib here and the screw and go to part workbench, and there's a neat tool here called a crosscut, cross sections. Click that, and I would like to view this from this one. That one might would work too. Let's just use this XZ. I'm going to need to adjust this position. Get it roughly in the middle. It doesn't have to be exactly. And select OK. So now we get a couple new objects. Let's hide some of this other stuff. And we'll select the front view. Zoom in on it. So our screw went in too far, but that's okay. Like I said, it's okay for the screw to stick out some. We just don't want it to be too short. So it's going to go into there. But it looks like it's too tight of a fit. That's not going to fit in that hole. Turn that back on so you can see. And let's go to wireframe again. So hopefully you can get an idea there. Let's go back to as is. The screw is going to not quite fit. Although it might, the way this is built, the way this is cut. But what I would like to do instead is enlarge that hole for this pocket just a little bit to give us a little bit more clearance there. So I'm go up to this sketch here. And it's set to set screw diameter. I think what I'll do is I'll change that in the DD property to 5.25, and you might choose a different value if you decided to make this. And now let's redo these cross sections because they're not parametric. Select these two. XZ again. Let's see if what we're looking like over that. Okay, that's good enough. And look at these again. Hide those. Yeah. So now we got enough clearance that screw is going to be able to fit in. Assuming you would be using these M5 screws. So that would push that gib in against that other that other part. There we are. Push it in against there and give us plenty of meat left, and yet also be able to hold that gib in place. So it's always good to double check these things, make sure you have enough clearance. Of course, you could always, I guess, drill that out again a little bit more, but it would be a kind of a challenging hole maybe, the way this is angled. I guess you could hold it in a vise against these two faces and do it. So that's going to do it for today. Thank you for watching, and as always, have a great day. By the way, if you know of anybody who you think might be interested in these videos, by all means, let them know about it. There are a lot of folks out there buying 3D printers now. The price is coming down and the quality is pretty good for the price. But they might not know the CAD part. So it's certainly very useful, a useful skill. And even if you know someone who does not yet have a 3D printer, if they can learn the CAD, that's the way I did it. I learned the CAD first because I wasn't sure I'd be able to figure this out, and so I bought the printer after learning the CAD. So if you know somebody who has an interest in this type of stuff, let them know about these videos and how easy it is to learn FreeCAD. So once again, thanks for watching and have a great day.